Okay. Yeah, so let's go to MATLAB. Let me move this one here.
Can I ask a question before we start?
Yes, of course.
I was doing homework for and did most of it effectively. I worked on to problem, like the second to last problem, and I just couldn't progress anymore. Are we gonna cover content that's covering homework 4 in class today, or
which one is that? Which question is that? Let me open the homework 4. You said, no?
yeah, homework 4, the one that's due on Wednesday, right?
Yes, on Wednesday. Which one are you looking for? The number 7?
Yeah, I was looking at no, number 6 and 7 actually.
Yeah, no, we are going to do today. You're going to be able to solve number 6 today, and number 7 is going to be for next Monday because I need to do more stuff. I will give you some information.
Now, I guess how are we gonna submit homework 4 if we can do number 7?
You just submit until number 6, and number 7 is going to be a kind of independent one. Yeah, okay, we'll talk more about this one. So just up to number 6.
Okay, just up to number 6, and number 7 we'll do a separate file and submit it.
Yes, and you submit it exactly for part 2 or something like that. I need to provide you. I need to do a copy. I will talk about this at the end of the class today, just to explain you. You can do that, but you need some information here. Okay.
Okay. Thank you.
Perfect. What I was going to do. Okay, guys. So let's do a function here. Okay. Everyone open a function. We are going to prefer to use this one here. We can call this examples class, something like that. Okay, we are going to do what we are going to do now, guys, is something that's called loops. Okay, and let me share my screen just to present what we talk about loops. What are loops? We have 2 types of loops here, guys. In everything we do, we have. So let me do this by hand. And okay, so let's do first what are called for loops. Okay, so the command is going to be for, imagine I equals 1, let's say to 10. Okay, and we want to create a series. Imagine, guys, I want x to be 1, 2, 3 up to 10. Got it? And what we are going to do here, guys, is we are going to create our variable x, this one here. And for works with indexing. So normally you work in this way. So this means x position I, okay, is going to be equal to I, for example. Then I do my semicolon, and then I do my end. So this is the for loop. So it starts with for, from, this is my variable I will use, from where to where. You can do, of course, here increases, okay, from 1 increasing by 2 to 10. And in between is what you have is what you want to do with that. Okay, I'm doing here a very simple example that is indexing. Okay, so I is going to be, of course, when I equals 1, it will go here and it will say x position 1 equals 1, correct? Next time it will do, when I changes to 2, x position 2 equals to 2, etc. Do you agree with that? Makes sense to you? So the index is crucial here. So we need to understand how indexes work, guys. Now let's do a very simple example. Let's do this in MATLAB. So what we can do is for I equals 1 to 10. And I say that I want to create xi equals I, and then end. Do you agree, guys? It's not 1, sorry, equals I. Okay, so remember that if you want to show something here, just do a D, And D is anything. So let's save this. Oh, we saved this already. No. So let me save this one here. MATLAB files, examples class, good. So the D, guys, is simply something that allows me to do a debug. So just whatever, you can do E, F. I don't know why I always use D. And then you simply put the debugging button there and then simply run. Oh, well, you can here, you can do X. And here you have the values. Makes sense? Or just move the cursor, guys. You see that? Put the cursor on top of X. And then you see it, right? Make sense? Now, can you do another example with for loops? And now do the reverse. I want to start with 10 and go to 1. Do you understand? Do another for loop here and just think about that. How can you do, I want x1 to be 10, x2 to be 9, etc. Whatever, just create something. Do you understand?
So for the purpose of, I guess this is really just my industry instinct forcing me to do this, but wouldn't it be better if we initialize an empty list and deposit the content of xi here to show?
Yeah, well, you know what? What is interesting for the for loops, you don't need that, but you can. Yes, what your friend is saying, guys, is the following. Yeah, but in that case, you know what? MATLAB is smarter than that. Let me cover that in a couple of examples. Okay, because for this one here, it's much better to do this. I will cover what you said in Yana. Give me some time. We're gonna cover that too, Kevin. You can do it, but you know it's not efficient in terms of programming here. All right, here. Okay, someone? I will copy this here and then you do whatever you want. Someone wants to do this, guys? Who wants to do this? You can do whatever. You can change whatever you want. Okay, so we're doing for loops, Ryan. And this is the first example. So this creates 1, 2, 3, 4, 5, 6, 7, 10. So it is basically 4. I starts at 1 and finishes at 10. And this is X position I. So it would be changing position 1, 2, 3, 4, etc. And then you simply put it I. Okay, this is an example. Now what I want you guys is to start at 10 and to finish at 1. Someone? 1 more minute, okay?
I guess I could do it, Professor.
Yeah, so let me, okay, Kevin, all yours.
I see about 2 ways of doing this actually, but
Here we go, yeah.
let's just do a normal way.
Yeah.
I mean, this is really the simple solution. And
Good.
yeah. And then the other way to do it, I suppose, is that you could deposit an empty list in here and then every single loop you're just adding to that. Which, as the professor said, computationally costly, probably shouldn't do it. But again, here we are.
Try that. Yeah. Run.
Which one?
Both. Just one both.
Oh, I didn't even finish the. I didn't finish
yeah.
that.
Yeah.
You know, I'll just take this one out. Let's just run the other one.
Yeah. Okay.
Let's just run example class, and then let's take list off. I'm not sure I can copy and pasting, so I'm gonna have to type it.
Perhaps I'm not in the same directory. Wait a second. Yeah, you can run. You can run from here. Just where's my editor? Here. You go to here and just run. Yeah, D doesn't exist, so I'm saying.
Yeah, I mean we can just we could just theoretically we could just end it and then we just let it print. That's not a way to go about it. And then examples class, just press off examples class. Interesting. Wait a minute.
Why is that?
Oh, I made a dumb mistake because it's just going.
What it will do is it will do X. So remember, Y in your example is going to start at 10. Do you agree? So this is correctly. So it's doing X position 10 is 10, X position 9 is 9, etc.
Right. Yeah. It's not actually doing what I wanted to do effectively.
Right.
So probably.
You can change the indexing, right? No, that one can be easy. That one, you can change that one.
That one?
Yeah.
So I mean, do you?
No, okay. Not that one. Not that one. No, leave that one. The second example.
Okay, but in terms of indexing, I mean.
Yeah, what you can create, guys. Oh, let me do it.
Yeah.
Yeah. Wait 1 second. Let me. Look, guys. This is a good example of indexing. So if you start from here, 10 to minus 1 to 1, so this implies that the first I is going to be 10, correct? So what it will do is X 10 equals 10. So basically it's creating this stuff here. Do you agree with me, guys? Now, what you can do, just to use this one here, let's do a last outs, any variable. And you know what? I want to go to 10. Got it? So basically, you want this to be 1. So what do you do? So you want this number to be 1 when it's 10. So you want this listing a little. Look,
Professor, theoretically, indexing is still going to have to go from 1 to 10. The only thing that's actually changing is the value. So you just offset it. You no longer uses the I as a value indicator. Wouldn't that be a better way to go about this? And then create.
This is an empty. Yes, when you create empty. Yes, but I don't want to use empties at this point, Kevin. Yes, with an empty, you can do that. But let's start thinking about this one here. So remember that if I goes from 10 to minus 1 to 1, so what we are creating is 10, 9, 1, correct? If I do x of I, what I will be doing x of 10, x of 9, x of 10. So I want this one here. I want this to be 1, this to be 2, and this to be 10. What function, what can you do in the indexing to transform this one here? What can we do, guys? Think a little. Any ideas? Okay, think 1 minute. Just try to create a series that look like that. So I'm departing from this idea, no? I'm departing from the idea of starting from 10 to minus 1 to 1. Okay, you do something here and n. Perhaps you can create another idea for whatever n. Think a couple of minutes. You know, this is important just to be sure that you can get this type of ideas. These are sequences only. And I will show Kevin to request the empty matrix too. Okay. 2 minutes to think. Think. Just try. Try. MATLAB is not going to collapse. Just try different techniques, different examples. Ideas? So what about this? Imagine, what if I create a variable here that I think I call last something. And I call this, yeah, I can call this 10. Oh yeah, 11, okay, whatever. So now what happens if I create a variable here? Let's call j, and j is going to be last minus I. And then what I will use is x of y equals I. So what do you think is going to be creating? Just try. What happens with I equals 1? When I equals 10. J is going to be equal to what? 11 minus 10, so this equals to 1. So I'm having position 1. Position 1 is going to be equal to I, that is 10. Now what happens when I equals 9? J is going to be 11 minus 9, this is 1, 2. Correct? So position x position 2 is going to be equal to 9, etc. Make sense to you? This can be one way, okay? I just created now. I created this example right now. So this is one way. You can create many other different ways, but just try to create series, guys. In MATLAB series and R series are very interesting that help you a lot. So let's try to do this in our program. So if I say last aux can be 11, And then I create here another variable j that is going to be equal to last out minus last out minus I. I will not print this one here. And here I can write xj of I. Do you agree? Makes sense to you guys or not? So if I want to just run this one here, I can copy here. Do you see that? So this is my final result. But if you see, guys, what a for loop does is exactly that. It does one by one when I equals 10, 9, 7, blah, 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 and then you do it. Do you see that? Do you understand the process of for? It's one by one. Now, can you do this in a different way, guys? Do you remember? I want to have 10 to 1. Well, actually, you don't need to do anything. It's 10 minus 1, minus 1 to 1. Do you agree? So what I'm trying to tell you, and this is in a single process, what I'm trying to tell you guys is that if you can minimize the use of for loops, while loops, do it, okay? When you do these loops, it takes a lot of memory and time. Well, in this example, no, because there are only 10 processes. But if you can avoid the for loop or while loop that we're going to do in a minute, please do it, okay? Now, questions. Now let's go with Kevin's idea. There is another way, guys, that we normally use in more advanced loops, but let's define, for example, a variable y, and this y is going to be empty. Okay, so this is the definition of empty. Now, what I will do is I can create this one. And I can create this one. Okay, so now what I will do, guys, is I will not use the index. What I will do is I will use the empty matrix. And as Kevin mentioned, guys, this empty matrix, the advantage of that is I don't care about the index. Okay, so what I will do here is you simply type your matrix that is going to have store your variables. And then here's where you define how do you want to link? How do you want to combine them? I want to combine y semicolon. So this implies I will have one below the other one. Oh, no, sorry. Here I wanted to have one next to the other one. And then here simply what you want to add. Do you understand? So this works in the following way. So you create empty first. So you have identified, you have created a matrix or vector in this case that is an empty. Then I do my simple. And what I will be doing is y, the first time is going to be empty, do you agree? But when I equals 1, y is going to be empty joined with x of 1. So we create the first value. The next step, y is already 1. You add another number, so it adds more numbers. Do you understand this part here? This one is very useful. Here you go. You see that? Do you understand this part here, guys?
Professor, you're still showing X in your console.
What? I'm not using this one. Yeah, I'm sharing this one. Do you see this one, this part here?
We see this part, but the console still shows the result of X and not Y.
Oh. Yeah, here we go. Wait a second, I need to save this one here.
I think you need to end the function and you just let Y print.
Yeah, that's right. But I don't want to be just, here we go. Do you see? I want to be, when I do a D here, what I do is I'm stopping the program and able to basically hover over the variables. Why is not hovering now? No, because I haven't run. Yeah, you can see now. You can see what are the values when you do this small trick. Okay, guys, make sense to you? You want to do something? Okay, so you do this, okay? Just continue in here. So let me perhaps create something very easy for you. You know that let's do a matrix. So imagine, guys, that you have this very simple matrix: 1, 2, 3, 4. And I want from you guys to create a matrix that is 1 squared, so 1. This number is the same, and this 116. Right? So what I want you is simply to work with this. And now what is interesting, guys, is that remember that this position here is going to be position A11, A12, A21, A22. Do you agree? So what you need to do now, guys, is double for loops. So you can say for I equals 1, blah, 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 for j equals 1 to blah, 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 and then you do something here, and then you close this one here, and then you close this one here. Okay? So remember also, we have done last class if conditions. So we have if you have a condition here, you put something here, else, and then you do something there, and then you do an end. So we did this last class. Can you try to do, just mix this here? So here, what you need to test is if I equals j, for example, because you want 1, 1, and 2, 2, then you do something. Got it? So I want you to recreate this matrix with diagonals equal to the power, second power or square of the main diagonal. Hey guys, can you do that? Let's say 3 minutes. Give me 1 second, guys. 2 more minutes, guys. We'll solve it. One more minute. Okay, so let's do it. Well, let's do 2 loops, okay? So, and you can do as many loops as you want, guys. So I want so let me create first my X matrix. So this is going to be 1, 2, 3, 4, okay? So this is going to be my X matrix. So what I want is from I equal 1 to 1. We can, just to make it more professional, we can say size of X, comma. I want to do rows first, perhaps. Number of rows is 1, right, in size. Remember that? Then can I do another 4? Now I will do so. It's going to be 1. It's going to move row by row. So first row, second row. Then J is going to be the same, but now I will move towards the second dimension. Let's say 2. Right? Then we need to do something, and then we need to close this stack here. What do we want to do here, guys? It's not 1, it's I. J. Let's call it J. So what do we want to do inside? So remember that we want 1 square and 4 square, do you agree? So how the I and J are going to be to do that condition? What do we need to do? So think in terms of I and J, guys. That's crucial here. So I is going to be, for me, I is going to be number of row, and J is going to be number of column. So how do I identify these ones here? What is particular of these ones here?
I equals to j, which translates to a function if I equals to j and you trigger the square.
Do you agree, guys, or not? So basically what we do is that you need to identify what is the problem here. So what I want is, I want to do a condition because I just want to have the elements of the main diagonal. So what we can argue is that if I equals j, so take care here, pay attention here. This is not an equal, like a number, this is a logic. So that's why it's equal equals j. Then what I need to do, what I do, guys? So let's call another variable y. And y is going to have two dimensions, right? So y position ij is going to be equal to what? X position ij to the power 2. Agree with me or not, guys? Okay, so if this is not a condition, what I want to fill in this one here is I want to just keep the same variable x, something like that. What do you think about this?
It should work.
Yeah, guys, Jack, Ryan, Jameson, what do you think?
Yeah, I'm still trying to test it on MATLAB, but it looks like it will make sense and work.
Yep, just copy, but guys, please pay attention, okay? So you need to basically understand how this works with this very kind of a stupid logic, but just think about that.
Professor, can you try running it? I try running it and it's giving me arrows.
Yeah. Yeah, I can run this here. Oh. Yes, of course. I need to run first this one here. So I need to run from X. What's going on here? For J equals 1.
J equals to 1.
Yes, it's not 1. Sorry, it is. Oh, no, that's from 1 to size of X1. So let me see. What is this one here? Should be 2. Yes. So from I equals 1. And should I have closed something wrong? No. J, of course. J, here we go, from A equals 1. Here we go. Okay. Now it should work. Oh, what it created? We created a monster, guys. Ij is going to be I. Let me see. Why is it creating that for I equals? This is 1 to 2. This is 1. What is this one here? 2. Yeah. Oh, yeah. Do you know what? This is also an interesting example to how do we test this stuff. 1 and 2. And this also should be 1 and 2. Perfect. So it's going to be 1, 1, A equal. You know what? Let's do a debug. Okay. Remember this debugging? So let's start here. So what is I? 1. Guys, everyone is with me? What is J? Is 1. Okay, my question is 1 equal to 1? Yes. So a J, a Y of 1, 1 equals, this number, like that. Yeah. Give me 1 second, guys. Can you give me 1 second, please? 1 second.
Yeah, I ran it, by the way. It works on mine, but it came out as 1, 2, 3, 16.
Sorry, guys. Okay, this is a good exercise for testing. Now it works for you, Kevin? Yeah. Okay, so where it was. So so let's take a look to what happens. I will run once. I will continue run. So take a look to what is A. Why I have I, oh yes, of course, I need to clean Y. Because I have Y. You know, can we do the following, guys? I can use this Z, just not to confuse with the Y that we have created here. Otherwise, it's going to be creating the same variable. Okay, so let's take a look at this one. Here we go. So what it was doing, guys, it was using the Y that we created before, remember? Okay, so that's why I created a C variable here that is a completely independent variable. And then you have 1, 16, 3, and 2. Do you agree? Now, guys, please, while you copy here, what I want from you now is the reverse. I want to keep the main diagonal equal. You know, the numbers don't change. I want 1 and 4 main diagonal. And I want the cube for the elements out of the main diagonal. So what I want from you basically is I want to create a matrix that looks like this. So now I want something that looks like this. It's going to be 1, 8, 3, 9, 27, and 4. Okay, using for loops. 2 minutes, guys. We can take a look to this. So I will copy and then you tell me. Let's call a different variable. So let's say matrix M. I need to share MATLAB. So I'm changing here instead of Z, I'm just using M. So what is my condition, guys? So what I do in order to take the off diagonal elements, what I need to do here in my if condition. We can change this if condition, right? Because what we are looking, remember the off diagonal elements, the I and J are different. How do we write different in MATLAB?
A tilde with the equal.
Right. So this one here is not equal to that. So this one here is going to be equal to cube. Otherwise, simply keep the numbers. Make sense to you guys? It should work. Okay. Let's try. Yep. Yes, sir. Questions? So it's a cube of, this was 2 to the power 3, 3 to the power 3. Okay, one more. So going back with A, what I want is I want you to compute the transpose. So basically transpose is going to be 1, 2, 3, 4. So this one here, if we call this A, this one here is simply A transpose, okay? But I want you to use the for loops that we have been using to create the transpose of this one here. You don't need if conditions, you simply don't need if conditions. For 1 minute, guys. So we don't need this one here. And remember the transpose is simply when you shift the I to the position of the J and the J to the position of I. That's it, you agree? You shift the positions. So what we can create is a matrix Nij. Oh. And I want this to be equal to Xji. What do you think about that?
Yeah, that's one given in the homework, right?
Yes, exactly. And that's the one that you need to modify. Yes, I will talk in a minute about this stuff. So now we can talk about that. Here we go. Okay, copy here, and then let's talk a little about the assignment. Okay, let me show you the assignment. Oh, not this one. Where's the assignment? Yeah, this is assignment, guys. So you need to create a function that looks like this, what we have done before. When I told you guys, do this general M file implies that you need to have inputs here, so parentheses, and outputs in brackets. So that's all. So I can provide you, or you can test with another variable, another matrix here. So the matrix here is going to disappear, right? It will disappear. And what I want is basically, if I give you a matrix, like the one that we have been working, so simply enter, run your program, and you should be able to do the transpose, to perform the transpose. Okay, using the for loop. This is number 6. Okay, 7, leave it, because I need to provide you some. I will do some, I will do a PDF, and then I will send you this to you.
Quick question before you exit out. Sorry, I just have a little, well, actually a lot of trouble understanding what you just said about number 6. But in the questions is computer transpose using for loops and some array approaches and also MATLAB way to estimate this.
Yeah.
What exactly are you saying
A
here?
prime, you know that, let me show you. Yeah, this is, where's MATLAB now? Where's MATLAB here? Here we are. So remember that MATLAB has already built-in commands. So A transpose is this one here. Oh, I don't have A, sorry, this one here. Just to show you that indeed your result is exactly the same as the one that you use with MATLAB. Got it? And then what we want, when I tell you, I want something that is more robust, so you need to put inputs here, you know, as we have been doing, and then you can have X, and then you need to input here. So this is what is more generic, MATLAB. Something that can be called from outside is a more generic MATLAB code. Yeah, you got it? Got it?
Okay, so to my understanding, you want a more general MATLAB code. Pretty much just says that something that can give you an input and an output.
Exactly.
That's what you mean by, and then compute a MATLAB way. That's just essentially adding
prime.
Yeah,
It's just type
adding a little prime, just for the sake of it, so we can check it. Yeah, okay.
Exactly. You just check that what you get, so I can see when I run this your program, I can simply click, and then I can see 2 tables, two matrices that are exactly the same. So this implies that your code is exactly the same as the MATLAB one.
Got it. So nothing too crazy. Essentially just
No. Simply that. Okay, guys. So now let's go into another type of loops that are called the while loops. Okay, and you're gonna see the intuition here, guys. Today and part of Wednesday class is going to be the last one that we're going to be doing language. Okay, the learning the basic. Now we're going to start programming on economics and finance a lot. So please, you need to study this part here. You need to remember all the things that we're doing here. Now, if you want to do a while loop, guys, this works in the following way. So you normally, I will set, you set something, the starting point. I'm sorry. So let's say I equals 1. Okay, so you set a starting point. And then what you do is while, let's say I is smaller or equal than 10. So you do something and then you end. what I want to create is, again, guys, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So I want to do a sequence of 1 to 10. So now from here, what I say is the following. While I is less or equal than 10, do the following. Just simply do x of I equals I. Okay? And then what you need to do here is the incremental number. So I is going to be equal to, wait, oh yeah, this is right. I equals I plus 1. And that's it. So what it does is the following. For loop increases immediately here. The while loop, you need to create a counter. So it's not 1 to 1. So it's going to be I plus 1. So this implies the following. When I equals 1, is 1 smaller than 10? Yes. Okay. X position 1 equals 1. Then the next I is going to be I, the original I, that is 1 plus 1, 2. So now I equals 2. 2 is less than 10, yes, and it continues doing this until it finishes. You're going to see the use on the for and the while, guys, soon. Okay, just remember what is the strategy, how this works. So if you do this, yeah, these, of course, it's nothing.
Professor, maybe try not setting
What?
I equals to 1 and just run a while loop without I equals to 1.
What is that? What do you mean?
Like I just ran the while from while to end without like inputting I equals to 1, and it worked for me.
Oh, yeah. Oh, yeah, it didn't run. What? Yes. Wait a second. So why is doing this stuff? Give me 1 second. Let me be sure. So let me be sure we are here. Okay. I equals 1. Is this one? Yeah. Let's test. X of 1. Again, guys. Let's don't call X. Let's call this K, for example. Okay. So now we should be okay with that. So remember, if we are using X is going to be something defined already up. So now we can run, and here we go. You see? So take a look. It does 10. Is 10 smaller or equal than 10? Yes. So K of 10 equals 10. And it creates this part here. Now it adds one more. Now it's 11. Is 11 smaller than 10? Nope. Okay, end up. Out the while loop. Okay. Yeah, guys, I think I sent you this one in the morning. Can you please open one file? Where is the file? 1 second. So let me see if I have sent this to you. Yes, I sent this to you. Can you open the file my loops 1, please? Can you open the file? I sent you this today. My loops. This is my loops 1. Wait a second. So give me 1 second. Yeah, that's okay. So can you please open my loops one? This is what you have there. Okay, now can you just comment for a minute the function? Just copy down just to be able to run with the data here. Okay, and copy this one here. So I'm not inputting anything. Okay. Now, can you have let's say 5 minutes to understand this code? Go line by line and understand what we're doing. Okay, what is the logic of what we're doing? Can you please do that? Are you with me, right, guys? So you can click I do at the D just to debug.
Wait, so Professor, can I go back very quickly to the top?
Yep.
So you commented out the first line, did a function my loops one. Okay, just so we can input those data.
Exactly, directly in the program.
Yeah.
Yep. Okay. Let's say 5 minutes, guys. Please invest this time to understand line by line. We're gonna do this, but it is, if you can read this code, we are in a good position. And you can run, guys, just do the dots here, and then you can see, oh, what's going on, what are we doing, etc. So just work with this. One more minute, guys.
Professor, question about line 21. Was that while loop really necessary, or was it just for
No.
Yeah,
Yes,
I was
it's
about
them
to say.
only. Yeah, yes. Most of these things, guys, are not needed. You can do this in a single line of code, but just for showing you how this works. Yes. Ready? Ready? So let's take a look to the data, guys. So we have ID is the first column. What is the other one? Years. What is this one here? Yeah, this is years of education, I think, I imagine. These are the salaries and the gender. Okay, just a toy example. ID, years of education, salaries, and gender. I don't know, perhaps one is male and two female, or two female, one male, it doesn't matter. Okay, so what I'm doing here is I'm creating an empty matrix, what we did before. So let's do this, there's nothing here. You can see only males is empty. And then what I'm doing here is the size of ID years, comma 1 gives me the number of columns, sorry, number of rows. Basically, we have 6, right? If we take a look to this one here, yes, we have 6. So we are going to do a loop from 1 to 6. And then what I will do is I will say, you know what, if position number 4, remember, represents a gender. So males equals 1. So if element in column 4 equals 1, increase the only males that is empty at the beginning, just right below all columns, row I. Make sense to you guys? Guys, make sense? So remember, this is the way that in which we use an empty matrix. We copy the same name, brackets, copy the same name. If I put comma, this is going to be a row vector. If I write semicolon, it's going to be a column vector. So if you do that, so you don't see this, but you take a look at that. So individual number 2, 4, and 5 are males. Do you agree? Okay, so now what we do is using while loops, create a matrix with years of experience that is more or equal than 8 years. Okay, I create another one that's called, another variable is called +8 equals empty. I create my counter. I start my counter at 1. And then what I do is the following. While k is smaller than all the rows of this matrix, do the following. Do a condition. If ID years gender K2, this is the number of years of education, is larger or equal than 8, you simply start filling my +8 matrix. And then you need to add a K, because remember, it's not like the for loop that creates immediately the counting in the for command. Here you need to create an internal counter. Okay. You simply run. We can take a look to +8 at these guys here. So you see, individuals 1, 4, and 5 have more than 8 years, more greater or equal than 8 years of education. Finally, what I'm saying is using the original matrix, add a new column to contain salary level. 1 is going to be high if it's larger than $100,000, or 2 is going to be medium if it's larger or equal than 50 but smaller than 100, and 3 if it's smaller than 50. Okay, so what I do is the same. I go from I'm gonna be reading all rows. Then I say the following: if ID years gender 3, so this corresponds to the salary, is larger or equal than 100, so you simply so I'm using the same variable here, but I'm adding a new column number 5. So remember, the original one has 4 columns only, but now I'm using 5 columns. I'm saying 1 is going to be high, I think. Yes, high. Then I do a second condition. It's larger or equal than 50,000 and it's smaller than 100. You simply put position number 5, 2, and otherwise it's going to be 3. So here, guys, one thing that you need to remember, I have if you have several other conditions, the way of doing this is else if, and the last condition is the one that should be else, and then you close by end. Questions, guys? Do you understand this one here? So this is a new one for you. If, else, and end. So this is the complete structure of the if-else condition.
Professor?
Yes,
If If you had more conditions to check out, would you write it out as if, else if, else if, else
No,
if,
no, no, no.
else and?
No, else if, yes. So it's going to be if only one. If is only the first. Else if you can use as many as you want.
Okay.
And else is the last one. So basically what I'm telling to you is this one here. So imagine the generic structure is going to be if, else if. You can have else if again. You can have another else if. The last one is going to be else, and then you end. Got it? So you can have as many else ifs as you want. Make sense, Jameson?
Yeah, thank you.
Perfect. So now let's go here. Okay, I can stop here. Oh, let's see. Any questions about this part here? Is easy? Of course it's easy, guys. Once you see it done, it's easy. And then you can take a look to the new matrix. So the new matrix has one, the last column is going to be high income. So I have high, medium, low, high, and medium. You agree? So that's the way you read the last column. Correct, guys, or not? So what I have done here, what is this one here? So if you want to know what is this here, guys, just do a bullet here, 43, just run. And take a look to this is one. What I've created here, remember guys, when I initiate a matrix, I can initiate this as an empty, or I can initiate this as any numbers. I can do ones, 99, or zeros. In this case, I have initiated a vector that's going to be 6 times 1, and it's going to be filled full with zeros. Got it? And then after that, I'm doing, I don't know, something simple. Yes, if it's males, what I'm doing is now, as soon as I don't have the empty, so I don't use this technique of filling the data, I don't use this one here. Okay, what I'm doing is replacing each column, each row. So if ID years equals 1, I4 equals 1, you simply replace that particular position with ones. So what is going to be the final result here, guys? Remember that if you run this one here, so this is only males, you only get the rows that satisfy the condition. Do you agree? However, if I want to have a 0, 0, 0, 1, 1, etc., one that satisfy the condition, the technique to do that is this one here. Take a look to what happens. You see the gender dump? So it is 0 if it not satisfies the condition, 1 if it satisfies the condition, 0, 1, 1, 1, 0, 1. Makes sense to you guys? I need your input because I need to understand that you understand this part here. These are toy examples that we're going to be using in more complicated examples later. Make sense?
Yep.
Makes sense. Yeah.
Yeah, perfect. Okay, guys. So let me stop here. Let me clear my breakpoints. So you have this one here. So now let's go and let's do something. Yeah, I think I sent you this also. Yes. So can you please open the files that I send you, temps? So I can, my loops I can close. Can you open the file, temps something? I sent you today a text file. Where's temps? Yeah, I have sent you temps. Where's my open with? Yeah, let's open this with a notepad. This is a text. You see that? Oh, sorry, I need to share this with you. So if you open this in Notepad, guys, temps, temps.txt. This is a text file. Okay. So what we have here, guys, is a temperature of 30 days temperature of 3 cities. Right? So that's all what we have. Take a look, guys, when MATLAB, when we work with temps, txt, sorry, we don't need to have a text here. If it's number, everything should be numbers. So we need to delete the headings. It's going to be different when we use when we start using XLS file or CSV files. Okay, so now can you please open, where's my MATLAB here? Can you please open something that is called temps example underscore txt? Okay, I will explain the first part and then you understand all the part. So what I'm doing here is simply loading. This needs to be changed for where do you have your file. Okay, this address here, guys, you need to change this address. I don't know where do you change this address. And also, I think MATLAB, starting from MATLAB 2017, I think the command that we need to use is UI open. Okay, can you verify either it's load or UI open? I'm not sure in which version you are. Okay, can you please run up to here? Yeah, so it worked for me. So I have my temps. So we have temps is a text document. And then you see here, temps now I have we have 31 observations, 31 days, 3 cities, okay, city A, B, and C. Now, can you please run and understand what we are doing here? Say 3 minutes because this is very simple. Okay. Easy, right? So what we need to learn from this class, guys, is this is the way you load a TXT file or UI open. I think that this is for latest versions of MATLAB. So what I'm doing here is I'm counting number of observations, simply counts how many observations do I have, the size of temps. Okay, so let's run this part here. So I have 31 times 3. D equals, what I'm doing is running from 1 to nobs 1. So I'm doing a sequence of 31 observations. And remember, this is just to show you the use of some stuff here. So if I plot here, I have my common plot. That's why I need D. Why do I need a figure here, guys? Why? Why I'm writing this part here?
So you don't get rid of the old graph?
Exactly. So let me see, let me share my graph. You see my graph? So this is my daily temperature, guys. So this is city 1, 2, and 3. So you can see the temperatures in different cities. When I create figure, what I'm doing is I'm opening an empty figure. Then I will do the histogram here. And we can take a look to the histogram. So this is my histogram. Got it? So between 8 and 9, I have 10 days, 10 observations. Between 9 and 10, I have 3 observations, etc. And then from here, guys, what I'm doing is I'm simply doing, just using some statistics, the mean, the maximum, the minimum, the standard deviation, the difference, the correlations. What I'm taking here is part of temps. I'm just selecting those of CD1 that are larger than temperature larger than 10. So I will select all the columns. And then I'm just taking the correlation of all the parts. So if you run this, so this is what you have. Agree? The correlation, all guys, is a very nice command here, guys, because what you can do, you can not only select the correlation, but also the p-values. How significant are the correlations? Make sense? We're going to use correlations all the time when we start doing finance, guys. Make sense to everyone? Easy?
Yep.
Perfect. So now let's go. Let's start talking about. Let's start talking about Excel. Okay. So what I will do, let's assume I will just. Can you open please your file that is called also temps, but now it's temps Excel, the Excel one. No.
Professor, I don't think you send it to us.
Really? Wait. So let me be sure about that. Give me 1 second. Otherwise, I need to send this to you. 1 second. Temp save, temp txt. No. Seriously, no. Okay, so I will send this to you right now. It's not temps. Here we go. Okay, guys, you should have received this file now. Can you please verify? And I will open this file. So this is the file that we have, CT1, 2, and 3. Can you verify that you have this one here? So this is Excel, purely Excel. Do you have it?
Professor, we have city 1, 2, and 3, but we don't have any values in the.
No. Go to sheet number 1. It has.
Oh, got it. Yep.
Guys, do you have it now?
Yeah, I got it.
Yeah, perfect. So now remember that in Excel, yes,
Yep.
in Excel we can have titles, we can have whatever we want. Okay, so we can mix labels and we can mix letters. So this is more powerful than the TXT format. Okay, so let's go and let's start thinking about that, how this works. So can you close this one here, guys, because we're going to be saving also from there. Close this Excel file. Let me share my MATLAB. Okay, so let's call this N, or let's call this DAT equals, what you need to do, guys, the command is XLS read. You need to look for where the data is located. So let me see, where do I have this one here? I have this one here. Can you please check where do you have? And then the names of the file, the name of the file, temps.xls. In this case, is a simple old Excel. Okay, so when you enter a single output with a command XLS read, what it will provide to you is only the numeric part of the data. Right? So now, if you want to have not only the numeric part but also the text part, so what you do is in the output you simply do the first one is going to be numeric, and the second one is going to be the labels. So the command is exactly the same, but in the output you do two. This is numeric, and this is text. Yeah. Yeah, I wrote this incorrectly. That labs. These are names, okay? So that is numeric data and labels. And they are going to be separated. So you say CT1, CT2, CT3. We're going to start working with the CT arrays also. One thing that is interesting, guys, is that what you can do is you can select directly from Excel. So let's imagine that, let's call this date 1. And then what you do is you copy everything again, the same, but then you do -1. And take a look to what happens. You need to be sure that your Excel is closed, please, guys. Okay, you do it. And then don't do anything here. Go to your Excel. And you see that it has appeared something like that. Excel has been opened. And then you just select for fun, from A2 to C10. Just select.
Can't see it.
Oh. Now, do you see this, guys? So when I do the -1 trick in the Excel read, XLS read, this is going to open the Excel file where you have the data, and then you simply in the Excel file you simply select like that, and then you go back to MATLAB, and then you click OK, and then you select the data, the piece of the data that you want. Make sense? Another thing that you can do, guys, is you can, from here, you can select whatever you want. For example, I want from A2 to C8. Or perhaps only to B8. You can do that. Okay, so this is the range. You can also, if you want, you just want more specific, just to be sure that you're selecting the correct sheet. So you do sheet 1. Oh, I think that's the correct way. You can do that. Okay, so it is first the sheet number, tab number, and what range do you want to select? Everyone's with me? Yeah, you can close Excel that we have been working with. Oh, no, it's already closed. Do you have my MATLAB, guys? Do you see my MATLAB?
Yeah.
Yeah, so let's create a toy example. So this is my X, and I want to save this one in Excel, right? So the command for saving, guys, is XLS. So let me XLS write. Where do you want to put it? The name of the file. So we can do example 2021, something like that. And then you can do XLSX, the new version. And then you can say simply what you want to save. So I want to save X. I can do example XLS, right, 2031. Okay, makes sense to you? So the command is XLS, right? Where do you want to save the file? What is the name of the file? The extension of the file? And what is the data that you want to save? You just enter. Oh. And then look around. MATLAB files. Do you see my Excel or not? Guys, do you see my Excel?
Yep.
Yeah.
Right.
Yep.
Perfect. And then you save it. Okay, guys, can you please try? 1 minute to try. We'll go to MATLAB again. So let's create another matrix, guys, A. So can we close, please, the matrix that we have created, example XLS, right? Let's close this one here. I'm creating A, and what I will do is I will write this one here, but I want to write this one here in the same matrix, but I want to save this in a second sheet. So what I do is simply I can put 2. So what it's going to do is going to save. It's going to save under this name. This is going to be the same name from my matrix of my Excel file. But now what I will save is my data A, and will save in the second tab. Okay, if it doesn't have a second tab, it will create for you. You see? XLS has created a new file. And then let's take a look to, where's my file? You see this, guys? You see in my Excel or not?
Yeah, we can see it.
Yes, so we have done that. Okay, guys, now you have 1 minute to do what I've done, just to be sure that you can handle this. Ready? Questions?
I'm good.
Yep, perfect. So now can you please open, I send you another file that was temps example save. I think we have it. Temps. Have I sent this to you or not? Have I sent this file to you guys?
Yep.
Yep. Can you open this file? Be sure that that you put the correct directory, etc. So I need to do the same. Just be sure that you have this correctly identified for you, and then I will explain the first part, and then you are going to be able to directory blah blah blah. Yes. Okay, once you have changed the directory, guys, please let me know so we can discuss this. This example here is extremely important, guys, for managing text. Okay. Are you done? So I need you to change this part here because you need to run this later.
Yeah, I'm done.
Perfect. Okay, so if we run, take a look to what directory is. Directory, guys, is simply text. You see? You cannot do anything with this one here except something later. But basically, directory, guys, I suggest you to do this stuff here and then create this type of addresses that are going to make your life much simpler. You don't need to be typing every single time directory. You don't need to be typing all the single time this one here. Okay? Once you have directory, you know where this is going to appear. Now, my project name, guys, is text. Okay? So my project name is going to be temp safe. I will call this temp safe 1, just not to delete my previous temp safe. And take a look, it's also text. Project name is simply temp safe 1. Very simple. Now take a look to what happens here, guys. Can you please do click here, run U. So what is U? Let me copy this in here. This is U. So use, remember these are going to be the numeric part. This is going to be the labels. Do XLS read. What I want C uses, this is where my program is located. So it's joining directory, is joining project name .xlsb, and then it's going to be, here we go, and look for sheet number 1. Got it? So take a look to how this works. So this one here, the apostrophe, goes with this apostrophe. So this apostrophe creates this one here as a text. Then I need to create another apostrophe. This one here is for this one here. You see that? And this one here goes with this one here to close my apostrophe. So this part here is directory, is all this part here up to this part here. Then it joins with project name, that is temp safe 1, joins with this part here. Right? So this part is text, and I need to close this one. I need to add to this one here, this part here. Transform this one into text, .xlsb. And then I need to basically, I have these two here correspond to this one here. Then I need to do a comma. So a comma comes like that, apostrophe, comma, apostrophe. This one here, this pair here corresponds to this one here. Then you have sheet number 1, that is this part here. Sorry, this part here. You close the apostrophe, and then you add this part here, and that's all. And then you define this as a matrix. The way we do this, guys, this is a text definition. Okay, what it helps you is, you're going to see down while you analyze this one here, allows you to do this very, very quickly and repetitive processes. Okay, so you don't need to be copying C users, etc. You don't need to be copying all the time the project name. You simply write something like that, and then that's it. Okay, so take a look to what happens when you eval a string. So eval U implies execute this one here. So if you do that, oopsie. This is Pro MATLAB used. I don't have XLSB. Oh, because I don't have this one here. Oh yeah, I don't have this one here. Sorry guys, you need to put temp safe, regular temp safe. Okay. Temp safe is data. So now what you have is if you just type temps, you have the temps. So this is the data that you have, guys. I don't know what this data is. Don't remember that. Oh yeah, I think I understand.
Yeah.
So this is the original data. Yes.
For some reason, when
Yep.
I run with eval U, is giving me an error for you had to change the XLSB, do you? Or I don't know.
To your file. You know, wait a second. Perhaps you don't have this one. Let me send this to you. 1 second, guys. Perhaps you don't have the file, so I need to provide you with the file.
We indeed do not have a file.
That's the point. Yeah, that's the point. So give me 1 second. I need to send you one file. It is temp safe. Temp safe. Here we go. This is the data that we have. Now put this data wherever you want in your directory. And now try to run and it will run. Run up to here. Can you run up to here, guys? And I want to be sure that you can get the data. If we see temps one, oh, I can close this one. Temps. This is temps one, guys. Indeed, temps one is without all this stuff here. So temps one is only this one here. We are going to create all these ones here. Okay, the file that I sent is already created, but indeed, what you have at the very beginning is only this one here. Guys, do you see my Excel file? Guys?
Yeah.
Yep. Okay, so indeed the data set is only this part here. Okay, already created this one. Ignore these ones here. We're gonna create these ones here. Now, if you are here, are you able to run? So you are able to run evalu. So you have that.
Yep, it works now. It creates a 31 times 5 matrix, I believe.
Right, completely right. Everyone, Jameson, Jack, and Ryan, are you there?
Yep.
Okay, perfect. So now, guys, what I want from you is, take 5 to 10 minutes maximum to understand what I'm doing here. Okay, do line by line as I'm doing. Okay, so then what happens? What is these knobs? Try to understand. Oh, knobs is this one. Okay, understand. Stop here, and then run, and then you try to understand what I'm doing. So why I'm using say, what is the meaning of this SAV equals 1? What is that? Go ahead. 4 more minutes, guys.
Professor, question on line 26 of the of
Yes, Kevin.
yeah, question on line 26 of the 10.
Yep, I'm here. Yep.
So if you go down a little bit, line 26,
This
yeah,
one?
max
Yep.
observed equals the size. I understand what that does. That essentially gets a row, and then you use it on line 30. If you scroll all the way to the right, you put it as nums to string max obs plus 1. So this is why I get a little confused.
Yeah, so num to string, what it does, remember, so let's write 2. Okay, let's say xx equals 2. This is a number, right? What I will do is I will call x x2 and num to a string. So remember what we are doing up. What we are doing up is concatenating strings. Do you agree? So if you want to put a number as part of a string, you need to transform this one here, this number into a string. So this is going to be D2 up to, I don't know what is the number of observations here. So 100, imagine. So it's going to put up to D. These are strings. And this 100 is going to be transformed into a string. So it's going to be from D2 to D100. Okay?
Sure. My question is why a +1?
Oh, yeah, +1, I think is because the number of observations, I don't know where's my definition of this variable. Where is max ops? Max ops. Yes, so remember the first one here. So we have number of observations 100, but I want the first row to have the labels. So this implies that I need to go from 2 to 100.
Oh, okay. Yeah, got it. Yeah, because when you read, okay, that makes sense.
Perfect. 5 more minutes, guys, and then we continue. Please do one by one and then understand what we're doing. So NOPS is simply number of observations. D is simply number of rows. That's okay. This part is also easy. Some call, what I've done is I have some, oh, this command here is interesting, guys. What we are doing is we are summing temps 2 by columns. So this implies that I'm summing column 1, 2, and 3. Got it? And if you do the mean, well, I'm also computing the average. Mean also works with this. Number 2 implies give me the means of the columns. Make sense to you? If you write 1, what it will do is it will add up row by row and give you also the mean row by row. So for example, if I do this one, I will just call this one. You see that? It's different than this one here. Okay, 3 more minutes, guys. Explore, run, and see what happens with your programs. Three more minutes, guys, and then we continue. Hey guys, questions? So why I'm using this one here? What is the purpose of this one here, guys? Guys, what is the purpose of safe equals one? What is the objective of this number here, of this one here?
It's the initialization for line 25 if safe equals 1, and then
It is a condition, right? If I put 0 here or any other number here, what is going to happen is that the MATLAB is going to come here, is going to ask, is safe equals 1? If it's not, simply jumps and doesn't save anything. So basically what I've done here, guys, this is not a command, it's any name. If I want to save, I write 1. If I don't want to save my results, I simply put 0. That's what it means here. If save equals 1, okay, do this. Otherwise, you don't do anything. So max number of observation is simply the number of rows of temps. So if you can take a look where we can go here. You see, max number of observation is 31. Call names, this is going to be the column names, sum and average of the 2 additional columns I'm creating. And then what I'm doing is I'm saying the following. Okay, XLS right. We can do this. We can run this one here. So let me move this one here. So take a look to what is U. Read. XLS right in this directory. The file name is going to be temp safe.xlsb. Do the column name in sheet number 1. So let me type this here. Column name in sheet number 1 and position D1. You agree? So if you open your Excel file, guys, this is what I'm saying. D1, position D1, write sum. Well, an average, because I'm just starting the first one. So it's going to take D1, D2, D3. In this case, I have 2 names. So it's going to do these 2 at the same time. So this is this part here. Okay, so let me close this file here so that it can work. Then you eval, that's okay. Then what do you do next? The next one is okay, so let me again do U. What I'm doing now, guys, is the sum column. So what I'm adding is all the column of sums. I'm summing this one here. You see? And I'm adding them starting in D2 and it goes to D32. Okay? Remember that here what you have is only D. What I'm doing, guys, I'm transforming this one here. No. What I'm doing is I'm transforming this one here, that is 32, in a text. So that's why now I have here D32. Right? And then simply says, you know what, save the sum of columns in sheet number 1, start in D1 and save up to D32, and then it will save it. Okay, so if we continue, and the remaining one is easy, so if we can stop here. So take a look to the program, to the Excel. You see, what I've created is I have created these 2 columns. Agree with me, guys? Do you understand? Nice, perfect. Okay, so now let's continue. Let's continue. So now I do some descriptive statistics. I create some descriptive statistics. You know, I'm creating a temps original, just not to destroy the original data set, then I can work with that. I'm creating the average temp. I'm creating the average of the average temp. I'm creating the maximum temperature, etc., correlations, etc. Let's do up to here. So what I have here is a daily change. Where's my daily change? So this is daily change. Got it? And I want to write the daily change, okay, This is my file name, daily change, in a tab that is also called daily change. So I will create a daily change tab and start in A1. Right? That's what I'm saying. Then save the correlation all in tab number 3. So we'll create a new tab, start in position A1. And finally, create another, use average temperature, create a new sheet that is called average temperature, start at A1. So this is what this part is saying. So we can run this one here. Oh, yes, of course. I need to close this one here. And I need to run again this one here. Yeah. So if you open the Excel file, what we have created at this point is we have created this one here. Daily change. We have created daily change. We have created a tab that is called 3. And we have created another one that is called average temperature. You see? And then finally, we're going to create a table. So let me close this one here, and let's do and see how do we create a table. Yeah, here we go. So I can stop here. So what I'm doing here, guys, is I'm creating a table. You know, yes. Before doing this part here in the table, let's create ourselves a table, first of all. Okay, so I will create A. So before going to the program, I want to show you how the table works. It's very cool. The table is basically, you can create the tables, guys, in MATLAB, and then you simply export this to Excel or export this to Word, whatever you want. So let's create a table. Okay, so the table is defined like that. And then you first define what you want in the rows. So for example, I will create ages. Okay, so perhaps 21, 23, 24, I'm sorry. Yeah, 25 and 27 and 25 again. So this is going to be my vector of ages, okay? So what I will do is I create, for example, a vector of gender. I'm sorry. Yeah. I cannot. I want this to be semicolons because I want to have these guys also in. Okay, perhaps we have the age, the gender. We can have what else? The height in inches. I don't know, whatever. 55, 65, 48, 64, for example. This is my height. My weight, okay, so I can do, for example, 151, 52, 142, 158, 184, for example. These are my weight, okay? And then perhaps I can write the cities or states where you have born. So let's do New York, let's say California, let's say Connecticut, and let's say New Jersey.
Question on notation here. Why is there a curly bracket and not a solid one?
Oh, yes, because this is text. You see this one here? Take a look. No, well, actually, no, I can use also the normal brackets here. I can actually do that. It's not a big issue. You're right.
So both works. Okay, got
yes,
it.
both works. Both works. Yeah, because take a look to this one here. Okay, so once we have that, what I need to define is, okay, this is what is going to be inside the table. Okay, now we can define the labels here and the labels here. And what we define is we need to tell MATLAB, okay, it's going to be variable names. Okay, so what are my variable names? And then I will say, you know, it's going to be, the first one I told you was going to be H. Was going to be H. Where was the other one? Yeah, I say gender. What else we said? So I need to close this one. Age, gender. I said height, weight. Height. Weight. And perhaps we can say birthplace. Okay, so these are my column names. Then I can write my row names. Okay, and my row names are going to be, these are the names, yes, B, C, and D. Yes, I think I'm done. Okay, so first you input that, you input the data. Okay, the data is up to here, and then you start saying, okay, my variable names are simply my column names, and then you have your row names, simply the names of the individuals here, for example, and then you just enter. Oh, what I did wrong here. Well, let me see what's wrong here. Oh, yeah. So perhaps I'm wrong. Perhaps I need to use this one here in text. Why is not accepting this one here? Give me 1 second, guys. We need to see what's going on here. Yeah, semicolon, semicolon, semicolon. Okay, so okay, so let me think. This one here is correct. This one here is correct. This one should be correct. Variable names. Yeah, I don't know. Variable names. Okay. Yeah, these are okay. Closing this one. Then I have, oh yeah, of course. Remember, it's row names, guys, like that, with caps here. Yeah, I think. Why is it not liking this one here? Stupid me. Guys, I need to write table, the command table. Oh yeah, that works. Yeah, so it is A, so I need to write my command. My command is table, and then you enter the data. You see, age, gender, what's that? Height, weight, and birthplace. Can you copy this one here just to be sure that you're able to create a table?
Professor, can you just copy the command and paste it in the chat just for time?
Yes. So let me. Oh, right on. Can you check that in your chat in the chat room, guys?
Works for me.
Perfect. So, okay, guys, okay, perfect. Kevin, Jack, and Ryan, works for you?
Yeah, it works.
Good.
Excellent. Okay, so that's the way you create your tables, guys. And what is beautiful about tables is that you can, let's create another table, okay? So whatever, so I will create B. Let me, no. I just want to create B. And let me just create whatever. So let's do, I will just put this in not in order, okay? So B is going to be, for example, only 3. It's going to be female, and male, so only 3. I'm just organizing this as whatever, okay? So then I can have the ages here, so I can do older, 35 just to distinguish them, 33, and let's say 38. So this is going to be the age. And then I can write here the state, so I can move this stuff here. And the state, let's put this in, I don't know, Arizona. Oh man. Oh, yeah, Arizona. Let's do age. And let's do, and let's delete this one here. Then we can add the ages. Sorry, the height. We'll just put the height different numbers. So 65, 45, 58. And yeah, can add this one here. So I need to delete this one here. We don't need this anymore. And then I can do and my variable names are going to be, so the first one is going to be gender. The second one is going to be age. Age, the second one. Gender, age, birthplace. Gender, age, birthplace. And we don't have this one. Let's say, yeah, height and weight. Okay, so this part disappears. And the row names, we can call them E, F, G. So let me copy this for you. Well, first of all, I need to see if it works. Yikes. So copy that, guys, and there is something missing somewhere. Here we go. We need to have a comma here. Here we go. Guys, it works for you?
Yeah, it works for me.
Excellent.
Yep, works for me.
Okay, perfect. So now what is beautiful, guys, when you have different tables, okay, but the orders are different, etc. What you can do is you can create, let's create C, for example, and we're going to use here vertical concatenation. Okay. Let me, it's vert concatenation, and then we just concatenate A and B. You see? It organizes everything. It's a beautiful, beautiful command. If you have different tables, guys, with different information, same information that is common, other information is not common, what it will simply add more columns that are not common, and it will leave empty when you don't have information, and we simply create, put the other ones in order. Okay, this is a fantastic data handler, guys. This is very beautiful, this table command.
That is indeed a very, very useful data management tool.
Yeah, it is. It is really cool. It is cool. Guys, okay, so now you can go and invest 2 minutes on understanding this part here. Okay, the table that we are creating here. I don't need this. I don't need this. Where's the table here? Yeah. Yeah, guys, here we go. Can you please understand this part here? 3 minutes. So this is basically creating a table. And this one here, just to be sure works. Okay, guys, so what I'm computing here, guys, is, okay, compute the mean, compute the standard deviations, compute the medians, and compute the correlation matrix. Okay, the correlation matrix is a 3 by 3 in this case, and I'm just interested about the correlations of not equal elements, okay? So I don't want the main diagonal. So what I've done is I've selected correlation 1, 2 with correlation 1, 3 and correlation 2, 3. So this is this matrix here. And so your overall matrix to export is going to be this one here. Right? And then what you can do here is, guys, I can go up to here. And then I define my column name, I define my row names. And then what I started simply, writing where's my file? My project name, temp save, create a new sheet that is going to be called table, save column name, starting B1 to E1. So it's going to be basically mean, standard deviation, median, correlation. Once you do that, okay, now save the row names, and the row names start in A2, and simply C1, C2, C3. And then basically do this part here. What is this one? Oh, complete the data. So simply save all these metrics. Okay, so if you do that, and then you open the file, open. This is what you get. You see the mean, the standard deviation, the median, the correlation, etc. So you get your result. You can export this into Word, whatever you want. TXT is a lot of good things you can do. Okay, guys, questions? Oh, do you see my Excel? Sorry, I'm showing your Excel. My Excel, you don't see this. This is the result from the MATLAB program. It creates this table for you.
Question: isn't
Yep.
this kind of all menu? Why don't you just create a table and deposit it into an Excel sheet?
You can definitely do that. Yeah, this is a toy example that we have here. Okay, guys, questions? I think with that we are okay for today. Yeah, I will give you. I need you to explore this table. Let me see if I gave you this table here. So let's open. It's going to be table example. Table example.
Yeah, that's not a file we have.
Oh, again. Yeah, okay. So I will give you this one here, guys. And for next week, please, we are going to invest the first 5 minutes to explore this one here. And where's my, I need to send this to you again. Give me 1 second. I want to be sure you get this one here. This table example. Okay, please run. Be sure that you are able to run. And then this is the first thing we're going to discuss on next class. Okay, so let me be sure that I have something for you at this point here. Give me 1 second, please. Just give me 1 second. Need to see where do I have this one here. And next class, guys, we're going to start already programming seriously with a lot of. We're going to start optimizing all this stuff, okay? But let's talk a little about this question here, the OLS model, guys. Okay. Do you see my screen? Now, do you see this part here? Okay. So let me explain to you. How many of you have taken econometrics before?
I've taken it.
Yeah, perfect.
I have not taken econometrics yet.
Okay, don't worry about that. You know what you need to do, guys. First thing you need to do, please select any econometrics book. Okay, the most simple one. You know, Gujarati, for example, guys. Just go Gujarati. Okay, econometrics. I used to have a summary of the formulas, but in any case, so imagine, guys, that you have the following information. So you have y1. So this is a series of y's, okay? So yn. Make sense? So this is data. Got it? And then what we do is alpha plus beta 1 x11 plus beta 2 x21 plus, let's say, an error 1. And the same here, alpha plus beta 1 x n1 plus beta 2 x n2 plus error n. So these are series of data, guys. These are vectors. Do you agree? Yeah. Y is simply 100 observations. X, the variable x1. So this is the name of this variable is called x1. So it can be, for example, returns depend on the SP 500 returns, but also depend on GDP growth. Okay. So these are vectors. So these are vectors. So now the way you write this one here, guys, is going to be simply y1, yn in a matrix form is going to be equal to 1 x11 x12 1 xn1 xn2 that multiplies alpha beta beta 1 and beta 2 plus my errors, error 1 up to error n. Now this is a matrix. This is going to be an n times 1. This is going to be 1 to 3 is going to be an n times 3. This one here, and this one is going to be a 3. A 3 times 1, and this is an n times 1. And then you see the matrix rule. The resulting is going to be an n times 1. So all of them are n times 1. So we can solve the situation. So here, guys, in matrix form, this is simply y equals xb plus my error. Okay, so this is the matrix form of writing this one here. Now the objective is to find this one here. These are the errors. Okay, there are IID. Don't stress a lot with this stuff, guys. But in order to find beta, so you find an equation that looks like this: x transpose x to the minus 1, x transpose y. Right? And then you see this one here, guys. If you have data, this is linear algebra. Do you agree? You can do this. We know how to do the inverse. We need to do the transpose. We know how to multiply. We can find B easily. Correct, guys? Guys?
Yep.
Yep. Okay. So you know what you can do is, as I told you, just look for Gujarati. Come on. Or you can do, let me share this one here. Or let's take a look to what happens if I do move this stuff here. Let me do, I'm just Googling it. You see my Google, right? OLS algebra equations, something like that. Let's take a look to what we have here. Oh, it has a program. No, I don't want the program. I want just the algebra.
May I be so brave and say that this will be a lot easier to do in R than to do in MATLAB?
Yeah, but I want you to practice this one here. Yeah, this is a good one. Criteria. Yeah, you have here the algebra, guys. This is beautiful. Yeah, this is the one that I show you. You know, and then you simply, what you need to do in that model, guys, is simply compute. Yeah, the assumptions. You know, I will use this one here. I will give you this link. And I will provide you tomorrow, but I want you to program, guys. I don't want you to simply say, because there is an R command or a MATLAB command, ls.
I was
Okay.
really more indicating coding it out in R since the process.
No, I don't want you to call anyone. I don't want you to call any program. You need to create your own program. So just take a look to this one here, guys. Okay, and I will tell you exactly what do you need to do. For example, you need to find B. Okay, so for B, you need to use this command here. Oh yeah, I know how to find, no, this is not B, this one here. So you need to find B. This is the B estimate, equation 12. Then you need to find, I assume you have your R squared somewhere. Yeah, the assumptions. I will tell you what you need to find. Where's my top theorem? Where's my F test, my T test? Oh, here we go. Hypothesis testing, the robust white. Yeah, I will tell you guys what you need to do. But you see, it's pure linear algebra. It's simply multiplication of matrices, etc., etc., etc. I will tell you what to do, guys, and then that's going to be your basically your this one here. Okay, don't stress until tomorrow. I will see exactly what you need to do. It is easy. Don't stress a lot with econometric side. Just stress about the formulas. I find the formulas and I apply the formulas to my using MATLAB. I don't use OLS or don't use LS model from R, okay? Because it's already built up. This program is already built in. So forget about that. You need to create your own program. Make sense to everyone? Perfect. Okay, guys,
Yep.
so we stop here, and next class, can you please study one day? Seriously, you need to study, because what we're going to start doing now, guys, is more mathematics. So we're going to do optimization, we're going to find maximum minimums, we're going to do a lot of things that are cool, but I will be using all the things that we have been doing up to now. So you should be able to do plots, you should be able to call data, select data, clean the data, organize the data very quickly, got it? Create tables and all this stuff. So please practice, guys, one day. Okay, it's going to be extremely useful for you guys. Okay, so have a good day. Yes, yes. So have a good day, guys, and see you on Wednesday. Got it? Take care, guys.
Yep, thank you. Take care.
Bye-bye, guys. Take care.
Yep. Thanks. Take care.
Bye. So,
You're gonna have to pause the